Let's start this video with a quick review. This first example, we have power because I have powers raised to another power, but I also have a product. So I have to remember that this exponent goes to everything in it. So when it's power of a power, you multiply the exponent. So that would be x to the 12th, y to the 16th, z to the 8th. The next one looks very complicated, but if you notice that all of this does not have an exponent on the outside, but this does, it gives us a starting point. So we're going to start with this second part. So I'm just going to rewrite xy squared times, and I'm going to take my exponent to everything. So negative times a negative is a positive. 3 squared is 9. X to the 4th squared is x to the 8th, because when you're raising a power to a power, you multiply. Y to the 3rd squared is y to the 6th. And z squared is z to the 4th. And now we can finish multiplying. We always have our number first. So positive times a positive is positive. 1, remember, if there's not a number there, it's 1. 1 times 9 is 9. X times x to the 8th is x to the 9th. Y squared times y to the 6th. And again, if you're multiplying powers with the same base, you add the exponents. And then we just have our z left over. So the learning target today is the same as in the last lesson, simplifying expressions using properties of exponents, but today we're going to focus on negative and zero exponents. One of the first things you need to do on your assignment today is look at a table similar to this and fill it out describing the patterns. So I'm going to start here, and remember we're talking exponents, so I'm going to write this in exponential form. 2 is like 2 to the 1st. 4 is like 2 squared. 8, 2 to the 3rd. 16, 2 to the 4th, etc., etc. So we're going to work backwards. So we have, going backwards here, my base is always 2, so that stays the same. And what is happening to my exponent? If we're going this way, it gets greater by 1. So here we're going to have less than 1. So 0, negative 1, negative 2, negative 3, negative 4. And again, here we're doubling every time, which means if we're working backwards, we have to take half of it. So half of 2 is 1. Half of 1 is 1/2. Half of 1/2 is 1/4. Half of 1/4 is 1/8. Notice the pattern here and how these are related. 1/8 is 2 to the negative 3rd, where 8 is 2 to the positive 3rd. Or 1/4 is 2 to the negative 2nd power, but 4 is 2 to the positive 2nd power. And also notice this right here. 2 to the 1st is 1. So what does that tell us about zero exponents? This is just one example. You're going to do the rest on your homework. But here you can see anything to the 0 power is 1. And what about negative exponents? It tells us that really it's the reciprocal. So 2 to the negative 4th is really, and I'll make this in blue over here, 1 over 2 to the positive 4th. Just like 2 to the negative 3rd was 1 over 2 to the 3rd. 2 to the 3rd is 8. So 1 over 8. So to summarize that, any number to the 0 power equals 1. So a to the 0 power is 1. xy to the 0 power is 1. b to the 0 power is not 1, because the 0 only goes to the b. So this is 1, so this is a times 1, which is a. And then negative exponents, it's the reciprocal. So a to the negative n, we have to bring it down. It's 1 over a to the n. Here's a negative exponent, so it's the reciprocal. We have to bring it up. So it's a to the n. So I think of it like this. If we have a 2-story house and someone is unhappy in one of the levels, we have to make them happy. So if they're unhappy in one level, here we have to make them happy by moving them to the other level. If they're unhappy in the basement, we have to make them happy by moving them up. So if it's a negative exponent, we have to move them to the other location to make them happy. All right, here's some example problems, but before I do them with you, I want you to try them on your own. So please take a moment, write them in your notes, try them out, see if you can figure out what stays where it's located and what moves. So please pause right now. All right, so for this first example, 3 to the negative 2. The negative 2 goes to the 3. It's negative. It's not happy where it's located. So we're going to open up that basement door and move it down. In other words, take the reciprocal. So now I have 3 squared, simplified is 1/9. This one, though, the only thing that is unhappy is that x to the negative 2. 3 is just fine. So I'm going to move the x down, but leave the 3 in the numerator. So 3 over x squared versus 3, where the negative 2 goes to both the 3 and the x because it's in parentheses right in front of it. So we're going to open up the basement door, move it all down. So now I have 1 over 3x in parentheses squared. And please remember, once you move it, it becomes a positive exponent. But it isn't simplified because it has parentheses. So this becomes power of a product where that exponent goes to both the 3 and the x. So 3 squared is 9, x squared. That's our final answer. All right, this one, you can do this a couple different ways. I'm going to do the power of a power first to make it 4 to the negative 4th, and then bring it down, because it is a negative exponent. So now I have 1 over 4 to the 4th. And if I had to simplify that, it would be 1 over 256, I believe. All right, this next one, 8. Okay, this next one, it's a little hard for me to read, and I'm the one that wrote it. So regardless, I know that these exponents are opposite. I actually think they're f and negative f. F plus a negative f, because remember, if you're multiplying powers with the same base, you add the exponents. That gets us 8 to the 0 power because they're opposites, which of course we know anything to the 0 power is 1. All right, this goes to both, so that means this whole term, negative 2x, comes down. The exponent then becomes positive, and then we can simplify. So negative times negative times a negative is a negative. 2 to the 3rd is 8, x to the 3rd. Where this whole term is negative, so it has to come up. It's always reciprocal. You're always moving it to the other place. So now I have 4x in parentheses to the positive 3rd power, so 64x to the 3rd. All right, and then this last example. This first term, it has a negative exponent, so it's going to come down. So now I have 1 over negative 3x. I can drop the parentheses because this exponent was just 1. And then I have times 2y. And then just like fraction work, we can do that multiplication because we can't leave a multiplication symbol in a problem if we're trying to simplify. So now I have negative 2y over 3x. And the reason I put the negative up is generally we don't see it in the denominator. It doesn't matter. You can have it out front, you can have it in the numerator, you can have it in the denominator. I just like leaving it on the top.